Hello dear students, I welcome you all on behalf of IIT's GATE classes, an exclusive GATE coaching run by IIT IISc graduates, to the video solution on the subject control system of the branch ECE. Okay, so let us look into the questions that has been asked to the branch ECE in the subject control system from the year 2020 in GATE exam. So you can see in this question, this was actually 1 marks question. You can see this is the question number 11 that is in the question sheet provided by the IIT, okay, in the year 2020. So what is the question? The pole zero map of a rational function GS is shown below. When the closed contour tau is mapped into GS plane, then the mapping encircles. Okay, so this is the GS plane. Remember, this is GS plane, not 1 plus GS plane. Okay, in 1 plus GS, our Nyquist contour, it encircles -1 J0. Okay, -1 plus J0 point. Okay, it encircles, but in GS, okay, in GS it will encircle the origin. Okay, it will encircle the origin, and this encirclement, number of encirclement will depend on the number of poles and number of zero that are enclosed in the contour given. Okay, what I said, the number of encirclement it will depend on the number of poles and zero encircled by the contour. Okay, so in GS this encirclement will be of which point? It will be of origin. Okay, remember this. And if I want to write the formula, so n is equal to number of poles that has been encircled minus number of zeros that are enclosed by the contour, and this encirclement is in which direction? Is in anti-clockwise direction. Okay, if I want to write it for clockwise direction, same it will be what? It will be n is equal to z minus p. Okay, this is not the Nyquist criteria where we see p is number of open loop poles in the right hand side, z is the number of poles in the closed loop in the right hand side of S plane. It is not that formula. Okay, this is simple, the number of encirclements. So if I want to take any of the formula, suppose I take this one. Okay, so I have to find the number of encirclement. So how many poles are enclosed by this contour? How many poles are encircled by this contour? You can see it is 2. Okay, 2 poles. And how many zeros are there? Zeros are 3. So this comes out to be -1. So what does -1 means? -1 means there is only one encirclement in clockwise direction, not in anti-clockwise direction. Here I have considered the formula for anti-clockwise, that is why the result I am getting is -1. You can see here the rotation, the contour enclosed is in which direction? It is in clockwise direction. And here also you can see the number of poles are more than the number of zeros that has been enclosed by this contour. Okay, so this was quite obvious. The result we will be getting will be in clockwise direction. So the answer to this question will be what? The origin of the GS plane once in clockwise direction, option B. So moving on to the next question, this was quite simple question asked for 2 marks. Okay, the characteristics equation of a system is given by this. In the root locus plot for the given system, as k varies from 0 to infinity, the breakaway or break-in point lies within. So this was simple but quite conceptual. So they have asked you normal root locus, not inverse root locus, because you can see the value of k, it varies from 0 to infinity. So first you need to find the open loop transfer function from this characteristics equation given. So how do we do that? Let us see. So it is given s cube plus 3s square plus ks plus 2s plus 3k equal to 0. I have just opened the bracket. Okay. So now I will be segregating the terms of k. So if I do that, s cube plus 3s square plus 2s plus s k s plus 3 equal to 0. Now can I write like this? 1 plus k s plus 3 divided by s cube. Okay, I will take common. Okay, or else I can write one more step, 3s square plus 2s equal to 0. Now can I write like this? K s plus 3 into s square plus 3s plus 2 equal to 0. Now you can check, this is in the form 1 plus, okay, so they haven't told. So this is 1 plus GHS equal to 0, where I can say my GHS equal to what? It is equal to K s plus 3 divided by s. I will be factorizing this. So if I do that, s plus 2, s plus 1. Okay. So I got the open loop transfer function for this characteristics equation given. So let me plot the pole 0 map for this open loop transfer function. If I do that, you can see I have a pole at origin at s equal to 1, at s equal to minus 2 and a 0 at s equal to minus 3. Okay. So I have a pole at s equal to 0, s equal to minus 1 and s equal to minus 2 and a 0 at s equal to minus 3. Okay. So now tell me which of the following, means in the real axis, which of them are the part of root locus? Tell me, is this a part of root locus, this from minus 1 to 0? Yes, obviously it is a part of root locus. Why? To the right side, if I take a point here, okay, to the right side I can see the number of poles and 0 of the open loop system are how many? It is 1, and whenever it is an odd number, that is the part of root locus. Okay, so this part, it is a part of root locus, this part. Okay, is this part a part of root locus? Here if I take a point, a test point, and if I check the number of roots, the number of poles and 0 to the right of that point, I can see what? There are two numbers of open loop poles and zeros. Okay, open loop poles, here there are no zeros. So what I can say, the number of pole 0 is even. So this part, it will not exist in root locus. Similarly, this part, it will be also part of root locus. Okay, is this part a part of my root locus from minus 3 to minus infinity? This is actually my minus infinity. No, this will not be again my part of root locus. Why? Because if I take a test point here somewhere, you can see the number of poles and 0 to the right of this point is what? It is even number. So this will not exist. Okay, so this is not my part of root locus. So let me denote it by some other color. Okay, so this is not a part of my root locus. So the part of root locus is which one? Either this is this one or this one. Okay, fine. Now tell me one thing very clearly. When does break-in point occur and when does breakaway point occur? Think. Break-in point occurs when there is, in the real axis, there is consecutive zeros. Consecutive 0 in the real axis, then we have what? We have break-in point. And for breakaway point, we need consecutive 0 of open loop transfer function. Okay, OLTF. and here for breakaway point it will be consecutive poles of OLTF in real axis. Okay, so you can see only one such condition exists in between these two, and that is what? Between 0 and -1. So I can say there is a breakaway point in between 0 and -1. Okay, so if you see option A is your answer, you did not had to solve for the value of S in this question. Okay, by directly using the concept you can say that this will be the value of my, in between this point, in between the range of this, my breakaway point will exist. Okay, now homework for you people will be actually to find the value of S at breakaway point. Okay, what is the value of S at breakaway point and the value of K at the breakaway point. Okay, I want those answer. I want you to comment down below and I will see how many of you comment. Okay, I will tell whether it's right or wrong. Okay, so that is a home task for you people. You just comment it in the comment section and I will get back to you if it is correct or not. Okay, so the answer to this question is what? It is -1 to 0. So the next question, this is also very simple. A system with transfer function Gs is equal to 1 by S plus 1 S plus A, where A is greater than 0, is subjected to input. The steady state output of the system is this, the value of A is. Okay, so very simple question. We know that for a LTI system, if my input is sinusoidal, then my output will also be sinusoidal. If my input is what? Sinusoidal, it can be either sine or cosine. Here it is cosine. Okay, so let me tell you cosine only, cos omega t. Okay, so my output will also be cos only with a magnitude change and a phase change only. Okay, if the transfer function is Hs, so if I want to calculate its magnitude, it will be what? It will be H of j omega, and its phase will be what? H of j omega. Okay, so output will be what? It will be magnitude of H j omega, and what will be the phase? It will depend on the sign of this phase of the transfer function. So I have assumed it plus over here, so it will be plus angle of H j omega. So this is the property of transfer function, or I can say this is the property of eigen signals or eigen values. Okay, so if I solve with this concept, so you can see Gs is given as what? Gs is given as 1 by S plus 1. Okay, so this omega of the transfer function is this applied frequency, applied angular frequency. Okay, these are the same. So note that S plus A. So if I want to calculate its magnitude and phase, so what will be G j omega? It will be 1 divided by j omega plus 1 j omega plus A. So what will be the magnitude and phase? Okay, first let me write magnitude. It will be what? It will be under root of 1 plus omega square into A square plus omega square. Okay, and what will be the phase? It will be minus tan inverse of omega minus tan inverse of omega by A. So what have they asked us to find? The value of A. Okay, value of A they want to know. So here you can see my input is what? 5 cos 3t. Okay, here my input also has a magnitude, remember this. So if I want to change here, okay, if my input is a cos omega t, then my output will be what? A into magnitude of hj omega cos omega t plus angle of hj omega. Okay, so if I want to do that now, let me now equate these two values. Okay, this 5 and this cos 1 by cos 10 omega t. Okay, so let me ask you first. So this is my output actually. Okay, so let me copy paste this first. So this is the transfer function I got, and what is my input and output? Okay, so let me actually draw one thing for you people so that it will be simple. So this is my system where the gain and phase of the system is Gj omega, angle of Gj omega, and what is the input? It is 5 cos 3t, 5 cos 3t, and output is 1 by root 10 cos 3t minus 1.892, 1.892, fine. Okay, so now this 1 by root 10, tell me, this 1 by root 10 is basically what? It will be 5 into magnitude of the system. So what is the magnitude of the system? It is 1 by under root of 1 plus omega square into under root of a square plus omega square. What is omega? You can see here, omega is 3. Okay, omega is 3. So now if I put omega is equal to 3, so what will it look like? So it will be 1 by root 10 is equal to 5 root 10 into a square plus 9. Okay, so this root 10 gets cancelled, and it will be what? A square plus 9 under root is equal to 5, taking square both side. So a square plus 9 is equal to 25, a is equal to a square is equal to 16, which implies a is equal to plus minus 4. Okay, the value of a is coming out to be plus minus 4. But you can see they have given you the constraint a is greater than 0. So your answer to this question will be what? It will be 4. Okay, so this is the answer of the question. Okay. So now the next question they have given you is what? Consider the following closed loop system RS. Okay, they have given you a unity feedback system where GS is given by this and CS is given by this. If the steady state error for a unit ramp is 0.1, they want you to find the value of K. Okay, so what is the type of the system? Type of system. So type of system means basically the number of poles at origin of OLTF. Okay, so this is the type of system, and we know that for type 1 system we have finite steady state error, for which input? For ramp input. For unit step input the error will be 0 for a type 1 system, and for a parabolic input it will be infinity for a type 1 system. Okay, so we know that ESS is equal to what? It is 1 by kV. Okay, kV, and what is kV? Velocity constant. And what is kV? kV is equal to limit s tends to 0 s g s. Okay, means gs into cs here. Okay, the forward path transfer function. Okay, so let me first calculate kV. So what is kV here? kV is equal to limit s tends to 0 s, what is gs given they have, into 1 by s into s plus 1. So this is type 1 system, you can see. Okay, this is type 1 system, so that is why we will be having a finite amount of error. So k s plus 1 s plus 3. Okay, so this s plus 1 gets cancelled, this s gets cancelled. So your kV comes out to be velocity error constant, it comes out to be, so this will be k by 3. Okay, k by 3. So, and they have given if the steady state error for the unit ramp is 0.1. So they have given the value of ESS as 0.1. Now you just need to substitute the value of kV. So it will be k by 3. So you can write this will be k by 3 into 0.1, which is equal to 30. So the value of k is what? It is 30. So 30 is your answer. So you can see for electronics and communication in the year 2020, control system, the question asked, they were quite simple. Okay, there was no actually conceptual question, very simple questions from the basic actually. Even I cannot say the questions are moderate level, these are very simple questions. So if you people had very basic idea of control system, you could have solved all the questions of control system. Okay, so I hope you people enjoyed this session, and if you people have any query, so you can just comment in the section below. And also I need answers from you from the homework questions. Okay, and I will get back to those questions. Okay, so I hope you enjoyed the session. Okay, then thank you.